So here's example 3 from section 5.1 and the second subtopic, which is on RAM, the rectangular approximation method. Here's the question, or here's the setup. This figure below shows the graph of f of x equals x squared times the sine of x on the interval from 0 to 3. We're asked to estimate the area under the curve from x equals 0 to x equals 3. So we can envision this area as all of this space under here. And that's for sure an irregular looking area. So we're thinking, all right, let's go with our rectangular approximation method. Let's slice this up into strips and we'll go from there. But there's not a whole lot of detail given in this question. How many rectangles or subintervals? I'm going to make that a question here. How many rectangles? Should we use LRAM? Should we use MRAM? Should we use RRAM? So any of those are possibilities. I wonder what we should do from there. Well, we've already kind of got something like this done for us. It was in the previous question from the last video with y equals x squared. And we were trying to find the area under it. Well, we did it all. We found LRAM, MRAM, RRAM. We started out with 6 rectangles or 6 subintervals, and we found those 3. But you can see here on that last slide, we had a whole table. So maybe you're wondering, how did this table get created? Because it took us long enough to find LRAM, MRAM, and RRAM with 6 subintervals. That's just the first line. If we doubled that or doubled it again or went up to 1,000, surely no one calculated that by hand. And you're right. We have a calculator program for this, and I think we want to use the calculator program for this example. So I think the first thing let's do is just set up a table. So how about we have one column for n, and that's going to represent the number of rectangles. And then let's do a column for LRAM, and let's do a column for MRAM, and let's do a column for RRAM. And that way we can kind of see which of these has given us the best guess. And we're going from 0 to 3 here, but since we're going to use a calculator program, maybe we just kind of begin with 5 subintervals or 5 rectangles, and maybe move on to 10 or to 20, or I don't know, we could even go up to like 50 or 100 and see what happens there. So you should have on your TI-84s now a calculator program called RAM. I'm going to bring mine up here. So here's our TI-84, and we're going to hit program. And there it's the only app I have installed. The only program I have installed is called RAM. Let's hit enter. And you'll see program RAM, hit enter again, and that runs it. And here we get a choice. LRAM, RRAM, MRAM. We'll talk about trapezoid, Simpson's method, and the actual sum another day, but let's focus on the first 3. So I'm going to choose LRAM. And the first thing we want to do is tell this program what the function is. Remember that function was x squared sine of x. So let's do x squared times the sine of x. And there's that. We'll hit enter. The left bound is 0. The right bound is 3. And the number of rectangles, let's start with 5. There we have it, 5.155. So let's write that in, 5.155. How about that? That was pretty easy. And let's go back to that calculator program again. Actually, if we hit the graph button, we even get to see it drawn. There it is. And there's that area, and it's the same graph that we have on our screen as well. That's kind of neat. And we even have the area given here, 5.155, and that's found with LRAM. So there we have it. And then if you notice, this is actually the function we used here is now stored in Y1. That's how the calculator program graphed it. So let's go back to that program again. Hit RAM. Let's hit enter, and here we go again. Let's do the RRAM for this. And now since that function is already stored in Y1, we can actually just call up the Y1 variable. We hit alpha and then F4, and that brings up the Y variable menu, and we're just going to tell it Y1 is Y1. Let's hit enter. We're going to do 0 to 3 with 5 rectangles. We hit enter, and 5.917. So 5.917. Let's get the MRAM now. So if we hit enter again, that kind of ends the program. There's not a way I know of to get back to the original. So we got to hit program again, execute the RAM program. This time we're going to do an MRAM. That's option 3. And Y1 is Y1. It's already stored. We'll hit enter. Left bound 0, right bound 3, and the number of rectangles 5. Then we have it 5.897. 5.897. And we see here that MRAM is between LRAM and RRAM, but this time MRAM is quite a bit closer to RRAM. So you see how to fill out the rest of this table. I tell you what we should maybe do here is kind of arrow down here, arrow down here. Let's do the last one of 100. And I'm going to refer you to your book, page 279 is where you can find the rest of this table filled out. So let's go ahead and do 100 though, because I'm curious if these 3 approximation methods are same to the 3 decimal places from here. So let's do program and enter, and let's try that again. Program, there we go. Enter, there we go. And let's do an LRAM. Y1 is Y1. And hit enter, and we're going to go 0 to 3. And the number of rectangles is 100. Or I did 1,000. Oh, this is really working on this calculator. Oh, maybe 1,000 was bad. Oh boy. Hey, okay, 1,000, 5.775. Tell you what we'll do is we'll just stick with 1,000 and say 5.775. All right, let's test the calculator again. We'll try 1,000. Oh goodness. Let's try programs. Oh, we got to hit enter. There we go. Let's hit programs and RAM, hit enter. Let's do the RRAM this time. Our Y1 is Y1, and let's hit enter. And then our left bound is 0, and our right bound is 3. And are we going to risk it? Yeah, let's do 1,000. Okay, we're going to hit enter, and there's the calculator working. We see the little yellow circle-y dotted thing just kind of moving and working, and hopefully we get an answer. Oh, there it is, 5.779. 5.779. 779. Okay, so there's a bit of a difference, but it's within 4 1,000ths of each other. And let's see what happens when we do MRAM, and then we will end this video. So hit enter one more time. That kind of clears everything off. Let's hit program, RAM. Let's hit enter. Let's do MRAM this time. That's option 3, middle rectangles. Y1 is already stored in Y1. We're going to go from 0 to 3, and we want, oh gosh, we want 1,000 rectangles again. I'm sorry, calculator, you're going to have to work hard for this one, but I believe in you. There's our little spinny yellow circle again. It's still going. At least our battery is good here. Oh, 5.777. Ha! It's actually right in the middle, 5.777. So you can see that as we add more rectangles, as we go from 5 to 10 to 20, 50, all the way up to 1,000, all 3 of the rectangular approximation methods do seem to approach the same number. In this case, it's about 5.777. And once again, take a look at page 279, and you can see this full table already filled out. So next up is one from your textbook, exercise 7 through 10. It's all together, and it talks about a region using y equals 2x minus x squared, going from 0 to 2. And notice number 9 has you fill out a table. I really think you should use the calculator program RAM. So I'm just going to say that here. Use the calculator program RAM. And that's going to make this a whole lot easier to do 7 through 10. So those are assigned. We may have time to do them in class. I'm going to leave them be for now. Exploration 1, which RAM is bigger? We've had some talks about which RAM is bigger. This is an exploration that explores that a little bit deeper with whether a function is increasing, decreasing, or so on, if that somehow affects which one's an underestimate, overestimate, best estimate. So that's going to be something we leave for class as well, but it's going to come up in later videos and later sections also. So that's all we have for now. I'll see you in another video.